right, so yesterday we looked at histograms and producing a histogram on our calculator. So we've got a few examples of some histograms drawn up here. So now what we're going to do, we have to describe our histogram. So this is what we're all about. We're about displaying the data in a graphical way, and then we have to describe it or write a report on it. So the first thing we can look at is called the shape of the distribution. So remember how the data plays out or is pictured out? That's called a distribution. So we first discuss the shape. So there's three types of shapes that you can get. So the first one is symmetric. So you can see what it means is that it looks like a bell shape or pretty even. So if you drew a line down the middle, symmetric means you see the same thing on either side. It would be like a mirror, okay? So that's what symmetric is. Now, when you have positive skewed, so skewed means it's like, it's stretched out a certain way. When you have positive skewed, you have all the data up the front at the start. So you have a big, large, like a tower, and then it tails off here at the end of it to the right. Okay, so that's positive skewed. If you have negative skewed, you start off with the tail and you end with the large amount of data there. Okay, so you're going to have to comment. Make sure you use this page as a reference and don't accidentally mix them up, because there's lots of kids who do that, and I find if you stuff it up at the beginning, your brain seems to be set with doing it. So let's make sure we're picking the right one and learning it properly. All right, so we can talk about that. Now we can also have something called an outlier. So we might have had all the data and there might have been a random data piece that was a little bit odd. It was either, in this case, it was a little bit small than all the rest. So when you have a column or a tower sticking away from all the other data, we call that outlier. So we should probably comment on this one. So if I was commenting on this one's shape, I would say this one was negative skewed with outlier. Okay, so we do have to take note if there is an outlier. We have to mention it in our report. Okay, so there's our shapes. So that's one way we can describe our histogram. Okay, now looking at when we are talking about our histograms, we're going to talk about the center. So when we have two distributions and they're said to be in different center, if the values of the data in one distribution are generally larger than the values of the other. So if you have a look here, where we talk about the median, so the median here, we'll do a little bit more of this later, it's the middle value. So what that means is if you had your data all listed out from lowest up to highest values, so whatever, you had all your data, the one in the middle would be the median. Okay, so when you had them all sitting out there, the data listed out, the median would be the middle. So if you were comparing two, so say for example we were comparing this histogram E with histogram F, what we can see is the median's going to occur in the middle where all the where majority of the data is. So where those big tall columns are, that's where we're seeing lots of data. So here, the median's probably here, so the center. So if you look down, it's probably roughly whatever that is, like say a 7. But if you look at this, see how the shape of this histogram is the same in F, but its center, its median, is higher. So it's roughly about 11, 12 or whatever. Okay, so we can compare. We're going to work out how to do this to find the value of the median, but we do it a bit later in the next chapters. We're just talking roughly about the center. So with histograms, we definitely will talk about the median. The mean is more the average, and we'll use that for other things. So, but for the center, we'll talk about the median. So if I was talking about, say, this one down here, and I was asked to describe the distribution, what we would say, I would say here, I would go, it's probably, we're going to say maybe negative skew. So we're going to say negative skew with a center, and we're just going to say approximately, because we haven't worked out officially how to do it. So we're going to say approximately. It's where all the main values are. So they're going to sit there. So we're going to say roughly, I don't know what that is, but 37. So we'll say with a center approximately at 37. Okay? Okay, so the other thing we can talk about is the spread. So the spread is how the data ranges out, yeah, or is how the data, we probably might say how the data varies. So what that means is, so you're saying, when we say, oh, this is the minimum, this is the maximum, so we say it ranges through, so many values. So we've got two ways of recording the spread, okay? So the range is one way, so it's the highest value minus the lowest value. Maybe here, just next to it, let's write the range formula. We're going to say, we might write it as the maximum minus the minimum, because in our calculator, that's how they're going to talk about the highest value. They'll state it as the maximum, and they'll state the lowest as the minimum. So that's just the general range. Now, the IQR, the interquartile range, is when we take the third quarter mark and we minus the first quarter mark. So we call that quartile 1 and quartile 3. And what the interquartile range tells us, so the interquartile range, that tells us where the middle 50% of the data lies. So if you think about it, if you're already at quarter 1 and you go to quarter 3, there's 2 quarters in between there. So it would be 50% of the data lies in there. And why that's more relevant is because you're telling us where the middle 50% is. We're going to see all those towers, often in the first quartile and in the fourth quartile. In the beginning, we're going to see all those outliers. So there might be an extreme. So if we were looking at the range, that outlier is going to make our range look really big. But it's probably only one value sitting out there. So the interquartile range, it will not. So what I mean by that, and you might want to write this is a resistant statistic. Okay, so what that means is, and if you put underneath, not affected by outliers. So the outliers aren't going to change or make the value thing. But this one, so you might write for the range that the range is affected by outliers, because that outlier is going to be either the minimum or a maximum value. Okay, so interquartile range is generally a lot more interesting for us, and probably going to be more telling us what the trend is and what's going on. So when we compare the spread, two distributions are said to differ in spread if the values of the data in one distribution tend to be more variable. So can you highlight, because this is what they're going to use, this wording, more variable. So what that means is, when they say more variable, it's a larger range or interquartile range. Yeah? So if you're more variable, that number that you calculate for the range or the interquartile range will be larger than the other one, okay? So that's what they mean when they say, you say one's more variable. So if we have a look, let's have a look at this one here, this histogram here. So we've got the histogram starting at 3 and it finishing at 11. So if we were doing the range for this one, we would say 11 minus 3, which equals 8, okay? We can't work out the interquartile range as such because we don't have all the data. So we'll also look at how we calculate that accurately later. So we'll just look at the range here. So if you have a look at this one starts at 1 and finishes at 15. So its range would equal 15 minus 1, okay, which is 14. So write a little note there that this histogram is more variable than, so I should say histogram, I'll say histogram H is more variable than histogram G, yeah? Okay, so, and if we look, so yeah, we'll look at that. But, maybe this, and why we're probably not going to use the range though, if you have a look, this could be a possible outlier. They're a bit away. We're not sure for sure, and we will do tests. I'll show you how we can test for that too later, but that could be a possible outlier. All right. Okay, so another way to display data is a dot plot. So we've seen this when we were calculating our histogram on our calculator. Remember, it automatically did a dot plot, the first graph, and then we changed it. So this dot plot is another way of displaying data. So every data point is a dot, and when we have several data points the same value, we stack them up. So let's go and we'll do this one for an example, because you do have to sort of manually do these ones in there. So what you're going to do is we've got the ages in years of 13 members in a cricket team. Okay, so this is also, if we take note, this is probably the ages. What type of data is that? Do we reckon that is numerical? And which little subcategory do you reckon that one is? Yeah, I reckon more discrete, because we have counted how many years they're alive. Okay, so anyway, we're going to go through this, and the first one, just cross them off as you go. So we've got 1 on 22, cross that off, 1 on 19, cross that off, 1 on 18, cross it off. Then I've got my second one on 19, so I put it above, yeah? Then I've got 23, 25, 22, 29, 18. So make sure that when you're on your second dot, second dots should be in line with each other. And then we've got our third one on 22, another one on 23, one on 24, and another one on 22. Okay, so if you have a look, this is a dot plot, and we will start describing the shape of dot plots as well. This one's a little bit confusing because we've got a few possible outliers. So this could be an outlier out here. So I'm just saying possible because we haven't tested them. And same with maybe out here. So with this one, we wouldn't ask you to describe the shape. It's a bit everywhere, so we wouldn't ask you. But you could get asked, if the dot plot looks symmetric, you'll have all the towers in the middle, and it'll look like that bell shape, and you'll still get the same sort of image as the histograms for the shape. Okay, for a dot plot too, We don't like to do it if we have a lot of data because we would be there forever and it's not the best way. So this is a good display for low amounts of data. So what we say for that, amounts of data. So what I mean is when n equals a small number, yeah, a smaller value. So remember n's like here. So if we look here, n was 13. We had 13 members. So that's okay. We're not going to do a dot plot for 100 values or something like that. All right. So another way to display data, and this is numerical data, is stem and leaf, a stem and leaf plot. So just as you might just want to write that, a stem and leaf plot for numerical data. It can be discrete or it can be continuous. It doesn't matter. But for numerical data, this is a good display. Okay, so what you have is when you have a stem and leaf plot, you have the stem. So the stem part is here. And it's generally, it could be the first digit of the number or it could be the first two, depends what type of numbers you've got. So I'm going to say for an example, I might say, I might put this in there, these stems. So you go from smallest to largest going down. And then we might have, say we had a set of data. So say I had, I'm just making up these datas. Okay, so say that was our set of data there. What I'd do if I was drawing this data out as a stem and leaf plot, this number here, 0.1, I'd put there, and because I've got a 0.8, I put the 8 there. Now, I'll have to indicate that what I'm doing with a key. So you'll see a key, and all you do is put an example. So you'll say 1-2, that equals 1.2. Okay, so it might be, if I didn't put the key there, someone might think that's a 1 or an 8 if they were just looking at the stem and leaf, but it actually indicates 0.1 and 0.8. And then I would say, then I'd have a 2 here for the 1.2. Here I'd have a 3, and there I'd have a 4. Now, your leaves, so these are called the leaves out here, and your leaves must go from smallest to largest, okay? They have to be what you say, they have to be ordered. Yeah, so see how the 0.8 had to come after the 0.1 because 0.8 is bigger. So we go from smallest to largest. So that's very important that it is ordered when we do a stem and leaf plot. The stem and leaf plot is not one that comes up on our calculator. So we do have to create these ones ourselves. So we need to be wary of it. We're not going to have the calculator backing us up and ordering it for us. Okay, so it's a useful way of displaying data containing up to 50 observations. So when they say that, data of 50, so that means you'd say n is either less than or equal to 50, you know, so when we talk about the whole data set. So when before I said we say for the dot plots, we normally say for data less than 20 for that one. Okay, and it breaks it up into two parts, which we've talked about that, and the data is ordered. So you can see here we have they've done an example, and they've told me with the key for this one that 1-2 means a 12. So if I went over here, what does this number indicate? Yeah, that's a 59. Good. That indicates 59. Awesome. So what you're going to do, we're going to get this data, and we're going to have to obviously display it in a stem and leaf, and then we have to describe it. So if I showed you this, if I grab this data and I turned it round like that, would this not look like, it sort of looks like an x-axis. Would you agree? Yeah? And then we have our frequency along here. So does it look like, it sort of looks like a histogram with the towers? So when we do that, what shape do you think this thing looks like? Symmetrical. Yeah, symmetrical. Awesome. So we would say that this one, if we were describing this one, the shape, we would say, we'll just say approximately symmetric. It's not perfect, so we'll get away with it by saying approximately symmetric. Okay? So that's what you have to do when you have to describe the shape. You've got to sort of think about it and flip it on its side. All right, so here's an example. Let's go through this one for the stem and leaf. So the following is a set of marks obtained by a group of students on a test. Display the data in the form of an ordered stem and leaf plot and comment on the shape of the distribution. All right, so let's go and pop that through. So you have to be careful. We've got to have it ordered. So we probably, best way to tackle it is to go through and do the smallest numbers to the largest numbers and just keep adding it onto your stem and leaf. But first of all, the thing is missing is a key. So I've got to write a key here. And we've got whole numbers, so I just put any example. So I'm going to go 1-8 indicates 18. And so you must have a key. All right, so let's go through it. So, what's our lowest number? Looks like a 2. Would we agree? Yeah? All right, so we got 2. So 2 would go here. The next one looks like a 5. So 5. And then 7. So speak up if I get this wrong. And then the next one looks like we're into the teens. So what do we think is the next one? 15. Yeah. Now, so please make sure that you are lining these up. Yeah, they got to line up. Otherwise, the shape would be like not the correct shape. Okay, so we got 15. Looks like 17. Yeah, so 17. Then I saw an 18, I think. 18. Then there was a 19. So there was one there. I think there was a couple of 19s. Another 19. And there's 2 there. So 9 and 9. Okay. And then what have we got? Have we got any other ones? No. All right, 20s. I'm going to pause it. Okay, so what you want to do is obviously we want to have the amount of leaves will be the amount of data sets. So if you counted these up, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So they didn't tell me up here. So I know N is 25. So there is 25, there should be 25 leaves. Yeah, because N equals 25. Okay, so we've done that and we've set them out. So if I, just to help you out, if I flipped this on the side, what type of shape do we think that looks like? We've got sort of a tower here and then it stretches down like that. Yeah, good. So we probably say the shape for this one equals positive skewed. You can just write dot point like that for me. Just write shape equals positive skewed. And what we would say the centre probably heads in round in there. That would be where the centre is, where all the data is. But another thing they can ask us about, we might find interesting, is the mode. And remember we said the mode was the most frequent. So in this one, what's the mode of this one? What number did we see the most? Yeah, so the mode was 19. So we could talk about that in our thing as well, if we had to describe it. So it says comment on the shape. That's pretty much all we had to do. And we're going to say the shape is positive skewed. All right. I'm going to record on the video what someone mentioned. So if you do on your, on your calculator, if you go on your calculator, if you're on your calculator and you pop your list in, so if you popped your list in, list and spreadsheets, and then when you go to a data page, you know, so remember if we click and we select our list down here, so it will automatically produce a dot plot, okay? A dot plot, it's sort of similar to a stem and leaf. So if you take your cursor and you hover over it, it will tell you the number. So it's probably best to put your list in your calculator, go do this dot plot, and then draw out your stem and leaf from this so that you can hover and we won't make the mistake of, you know, we might miss one and like that, okay?